3 engines when everyone else chose 2 or 4, a design that ignored Western logic. It was the 1960s, and Boeing was perfecting the 727 for neatly paved American airports. The Soviet Union trying to land on frozen gravel at minus 40 degrees Celsius, where runway was more of a suggestion. So, Tupolev built something different, something that could take off from Siberian ice, survive blizzards, and still carry around 150 passengers across 11 time zones. The result was the Tu-154, a trijet that chose capability over efficiency, toughness over elegance, and survival over everything else. 1,026 were built and became the backbone of Soviet civil aviation. But that decision, 3 engines, built for the impossible, changed everything about how this jet flew, handled, and looked. What's that oval-shaped intake doing on the tail? Why do its wings droop downward when every Western jet's angle up? How did a passenger jet end up training cosmonauts to land a space shuttle? And why did its famously smooth wings start cracking after only a few years? Because this isn't just an aircraft, it's a case study in Soviet engineering logic. You're about to discover 10 extraordinary quirks of aviation's toughest workhorse, starting with Quirk 1, the Oval Mystery. Stand behind a Tu-154 on the ramp. The 2 outer engines, perfectly circular intakes, standard, expected. That center engine, stretched into an oval, like someone grabbed it and pulled. This isn't a manufacturing defect, it's solving one of the fundamental problems with rear-mounted engines. That center engine feeds through an S-shaped duct snaking through the fuselage. Air makes a sharp turn before reaching the compressor. The Boeing 727 had the same layout and sometimes suffered engine surging during aggressive maneuvers, the compressor choking on disrupted airflow. Boeing added vortex generators to smooth the flow. Tupolev went with a different direction. An oval intake on early Tu-154 models optimized airflow capture for the duct geometry. The stretch shape helped manage flow distortion around that crucial curve, contributing to stable engine performance even during hard maneuvering. Physics doesn't care about aesthetics. The trade-off? It looks unbalanced, but it worked reliably, keeping that center engine fed with smooth air through conditions that would have challenged perfectly circular geometry. If the engine intake looks unconventional, the wings challenge everything you know about aircraft design. Quirk 2, the upside-down wings. Stand in front of any Boeing or Airbus, the wings angle upward in a gentle smile. Positive, dihedral, basic stability, aviation 101. The Tu-154, its wings droop downward. This is anhedral. Western designers avoided it, viewing excessive negative dihedral as a marker of instability. Soviet engineers embraced it deliberately, with full understanding of the aerodynamic consequences. Here's why it makes sense. Those wings sweep back. Aggressive sweep creates substantial roll stability. Actually, too much. Add upward dihedral on top of that sweep, you get a sluggish aircraft that fights every turn, wallowing through maneuvers. The downward droop cancels that excessive stability, makes the Tu-154 responsive, maneuverable, and willing to carve through turns instead of resisting them. Soviet pilots throwing the aircraft around harsh Siberian airports needed that agility. Bonus benefit: anhedral naturally resists Dutch roll, that uncomfortable yaw-roll coupling that makes passengers queasy and pilots work harder. Western pilots call it questionable stability design. Soviet pilots call it responsive handling. Watch a Tu-154 bank a turn. Those drooping wings give it an agile, nose-down altitude. It doesn't float gracefully through turns, it carves them with authority. But those revolutionary wings had a critical flaw. Quirk 3, too good to be true. Early Tu-154 passengers raved about the ride quality. Turbulence? Barely noticed. Smooth, comfortable, like floating on air. Better than the 727. Better than the Trident, the smoothest jet in Soviet aviation. Then, the wings started cracking. Soviet engineers designed those wings to flex, absorbing bumps, instead of transmitting them to the cabin. They used advanced aluminum alloys, incorporated the latest aerodynamic research, and tested it thoroughly in wind tunnels. It worked beautifully for exactly 3 to 4 years of service. Then, metal fatigue appeared. The advanced aluminum hadn't been tested thoroughly enough under real-world conditions. Too flexible, stress patterns too complex, harsh Soviet operating environments, more punishing than predictions. By the mid-1970s, dozens of early aircraft needed major wing reinforcements or complete replacements. An airliner so comfortable, it was literally too good to be true. The Tu-154B got beefed up wings, stronger, less flexible, more conservative. Passengers noticed immediately. Rougher ride, more turbulence felt in the cabin, but those wings stayed attached. The oldest engineering lesson, relearned at enormous cost. You can't have everything. Soviet engineers learned to be more conservative, but one feature stayed brutally overbuilt from day one. Quirk 4. 12 wheels of Soviet steel. Count the wheels on a Boeing 737 or Airbus A320. 4 main landing gear wheels total. Boeing 777, 12 main landing gear wheels, but it's a massive widebody. The Tu-154, 12 main wheels, 6 per side, on a narrowbody jet roughly the length of a 757. This isn't overkill, this is survival engineering. The Soviet Union stretched across tundra, permafrost, and gravel strips, where airport meant optimistic thinking. The Tu-157 had to operate where Western jets couldn't dream of landing. Those massive 6-wheel bogies spread weight across an enormous contact area. Low-pressure tires, big, soft, forgiving. Together, they reduced ground pressure enough for unpaved runways, soft fields, and surfaces that would swallow conventional landing gear. But 12 wheels won't fit in a narrow-body fuselage, so Tupolev built those distinctive bulging wing pods. Those pods served multiple purposes beyond just housing wheels. Unusually long travel shock absorbers that could soak up punishment from rough strips. Built-in redundancy. Lose a tire, you've got 11 others. Inspection access without jacks, like a bomber's gear, because it genuinely could handle anything. The downside? Massive aerodynamic drag. Those pods murdered fuel efficiency, added weight, increased maintenance complexity. But efficiency wasn't the primary mission. Getting into remote Siberian outposts was. Connecting cities with minimal infrastructure. And those 12 wheels, they delivered exactly that capability. Over 1,026 Tu-154's served millions of passengers yearly, perhaps more than any Soviet jet in history. But while the landing gear was overbuilt, one part of the cockpit was definitely undersized. Quirk 5. The cramped navigator. The Tu-154 was designed for 3 crew: captain, first officer, and flight engineer. Clean design, logical layout, everything made sense. Then, somebody remembered Soviet regulations required a navigator. Not recommended, mandated by law. So, they crammed a 4th seat into a cockpit designed for 3 people. That navigator's workstation became the most compromised position in Soviet aviation, squeezed behind the pilots where it fundamentally didn't belong, working in afterthought space with minimal room for charts, instruments, or basic human comfort. Early design concepts included a glazed nose for visual navigation, following bomber lineage. Production models switched to a radar nose for better weather performance, but they couldn't abandon the navigator position, regulations written in concrete. So, he sat there, managing charts and calculating drift corrections in a jet whose inertial navigation system should have made him obsolete. The flight engineer behind, and to the right, monitoring systems. The navigator squeezed in somewhere else, fighting for elbow room. 4 people performing 3 people's worth of work in space designed for 3. By the Tu-154M variant in the 1980s, improved GPS finally let them eliminate the navigator position on simpler routes. But for 2 decades, 4 people worked in a 3-person space. Soviet aviation prioritized mission completion over crew comfort. The navigator seat proved it daily. And speaking of solving problems in unconventional ways, look at that tail. Quirk 6. The bullet on top. See that forward-pointing spike at the top of the vertical stabilizer? It's solving T-tail aerodynamics. When you mount the horizontal stabilizer high up on the vertical tail, pressure fields interfere. low-pressure zones merge at the junction, causing flow separation, buffeting, and shockwave formation at high speed. That bullet fairing breaks up the interference, less vibration, smoother airflow, better control authority. The 727 solved it differently. The Trident used a triangular fairing. Each manufacturer found their own solution to the same physics problem. But here's where it gets interesting. That spike evolved between variants as an efficient adaptation to changing needs. Original Tu-154, slender spike with small HF antenna. Tu-154A, fatter bullet, housing larger radio equipment. Tu-154M, even bigger, packed with additional avionics. You could identify Tu-154 variants instantly just from the tail spike profile. What started as an aerodynamic fix became valuable real estate for equipment. Solve one problem, create new capabilities, waste nothing. And those capabilities, they extended to features no Western jet ever considered. Quirk 7, built for winter. Most airlines worry about overhead bin space. Aeroflot worried about passenger survival. The Tu-154 had a feature no Western jet offered: instant coat check conversion. Those rear seat rows, quick-release floor tracks. Ground crews could remove entire rows in hours and bolt in massive wardrobe closets instead. This was winter configuration, not a luxury option. Essential equipment. When temperatures hit minus 40 degrees Celsius and passengers board wearing 20-pound fur coats, traditional overhead bins become useless. Those survival coats simply won't fit in normal storage. So, Tupolev designed flexibility into the airframe from day one. Remove seats, install wardrobes in winter, restore full seating capacity in spring. The floor tracks made the entire conversion possible in a single shift. Similar to the AN-24 turboprop's winter modifications, but unique among jets. Western observers found this unusual. Soviet operators found it absolutely essential. Try flying Norilsk to Yakutsk in January without dedicated coat storage. Try boarding passengers in Siberia who leave their survival gear at home. It reveals something fundamental about the Tu-154's design philosophy. This wasn't an aircraft optimized for seat-mile costs. It was designed for Soviet operational reality, extreme weather, passengers carrying survival gear, routes where a coat wasn't fashion, it was life support. That wardrobe wasn't a quirk, it was mission equipment, and the most unexpected mission, training for space. Quirk 8, the Space Shuttle Secret. The Tu-154 trained cosmonauts to land the Buran space shuttle. A Soviet trijet became the primary training aircraft for a spacecraft re-entering Earth's atmosphere at 28,000 kilometers. This sounds absurd until you understand the problem. Buran required an incredibly steep descent profile, much steeper than normal aircraft. The shuttle essentially fell like a brick with wings, requiring precise control during an extremely aggressive approach. The Tu-154's high thrust-to-weight ratio could replicate that dive angle. 7 modified Tu-154LL aircraft became flying laboratories, conducting over 140 Buran approach profiles. The cabin got trainee workstations. One station replicated Buran's flight deck exactly. But here's the remarkable part. After cosmonauts returned from space missions, they'd immediately fly a Tu-154 to test whether extended weightlessness affected their piloting ability. Igor Volk flew to the space station, Salyut 7, in July 1984. Immediately after landing on Earth, still readjusting to gravity, he climbed into a Tu-154 and flew a Buran approach profile. The Volk experiment proved cosmonauts could handle steep descents right after returning from space, critical data for future Buran missions with crews aboard. Those missions never happened. Buran flew once, unmanned, in November 1988, perfectly, landed itself automatically in crosswinds. By the time crews were ready for manned flights, the Soviet Union was collapsing. Funding disappeared, the program died. For a brief moment, the Tu-154 was the most important space program aircraft nobody outside the USSR knew about. And that aggressive performance capability, it didn't just serve cosmonauts, it defined the entire passenger experience. Quirk 9, the fighter jet experience. Passengers described the Tu-154 using the same phrase, a fighter jet pretending to be an airliner. The performance numbers tell the story. Typical cruise speed, around 530 miles per hour. That's comparable to the 727. 3 powerful engines, relatively light airframe despite the robust construction. The result? A jet that climbed strongly and moved passengers efficiently for its era. The climb? Intense. Full throttle to 40,000 feet in 10 minutes. Ears popping continuously. All 3 engines at maximum power. Nose angled skyward at angles that made passengers grip their armrests. The descent? Equally aggressive. Steep drops executed in 15 minutes. Bank angles up to 35 degrees in routine turns. But here's what makes it remarkable. Despite that performance, it could operate from 5,000-foot rough strips at high altitude in summer heat. Speed and short field capability, power and rough strip toughness. The Boeing 727 needed long, smooth runways. The Tu-154 could match its speed while landing on gravel. Fast, powerful, no-nonsense transportation. That high thrust-to-weight ratio wasn't just for short runways and space shuttle training. It defined the entire flight experience. The Tu-154 didn't apologize for being a performance machine. Aeroflot crews pushed the aircraft hard because they could, because it was designed for aggressive operation, because schedules were tight and weather windows were narrow, and that performance came from fundamental design philosophy. Quirk 10. Tough beyond reason. While earlier Tupolevs like the Tu-104 and Tu-114 directly evolved from bombers, the Tu-154 was a fresh civilian design, modern thinking for its era. But Soviet priorities infused it with ruggedness beyond typical airliners. Landing gear in wing pods, practical for the tri-jet layout, but built to bomber-grade specifications. T-tail configuration enabled clean wing aerodynamics while keeping engines away from foreign object damage. Oversized flight controls built for demanding operations in extreme conditions. This construction gave capabilities that civilian jets didn't usually need. Triple hydraulic system redundancy, genuine one-engine flight capability with meaningful performance, airframe structure overbuilt for environments that would ground Western aircraft. The Tu-154 could survive emergencies that would challenge supposedly more advanced Western designs. Stories exist of Tu-154's landing with severe damage, bird strikes that would down other jets, failures that became legends. Its accident rate proved comparable to contemporaries despite harsher operating conditions, though high-profile incidents highlighted visibility challenges inherent to older technology. That's not luck, that's Soviet-grade engineering philosophy. But it came at an enormous cost. Weight, complexity, maintenance nightmares, harder to operate economically, nearly impossible to modernize cost-effectively. By the 2000s, fuel costs and noise regulations ended the Tu-154's commercial viability. Too thirsty, too loud, too Soviet for the modern world. The last Russian commercial flight departed October 28, 2020. Conclusion: perfectly imperfect. So, what was the Tu-154? Those drooping wings Western engineers avoided? It made it responsive where it mattered. 12-wheel gear that murdered efficiency? It opened the entire Soviet Union to jet service. Flexible wings that cracked? They delivered the smoothest ride in Soviet aviation, however briefly. A cramped navigator station? Met regulations while pushing technological boundaries. Every quirk tells a story of engineers solving problems nobody else faced, problems that didn't exist in the West, problems that came from operating across 11 time zones in conditions ranging from Arctic winter to Central Asian summer. The Tu-154 proves there's no universal right way to design aircraft. The best solution depends entirely on the mission, the environment, the operational reality you're serving. And the Tu-154's mission was uniquely Soviet. Which quirk surprised you most? Ever flown on a Tu-154? Drop your thoughts below. Subscribe for more deep dives into aviation's most fascinating aircraft. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?